Hey everybody, this is Alex Merced from alexmercedcoder.com, and here we are in another video on this series on learning SQL in 2022. Okay, and in this video, what I want to cover is one, just thinking through like data relationships and what's called normalizing data, and two, using joins. Okay, in SQL. So first, we're going to understand the concept so you can understand why you want the joins and why you want to structure your data this way. So first, let's create a few CSV files. Okay, so we're going to call this like, we'll call it dogs owners. Okay, .csv. We're not going to really import this particular one, but this is just to show you sort of why we're going to need, why we really want to break up our data into different tables. Okay, so we will start off with just, I won't even bother with an ID here. We're just going to say like, owner name, dog name. Okay, and then we'll just say like, I'll just say O age for owner age. And let me just take some space away from over here for now. And then D age for dog age. So let's say Lisa, who's 33, okay, owns Biff, who is 4 years old. Okay, but Lisa also owns, and Lisa's still 33 years old, also owns Jake, who is 8 years old. Steve, who is 55, owns Butch, who is 6 years old. Okay. Now, do we see a problem here? Okay. Oh, looks like I had a little issue with the time resolving difference. Choose my changes. Choose server changes. We'll just let it do its thing. Okay. Cool. So now the problem we see with my data as it currently stands is that Lisa has been entered twice. Okay. And that should say Lisa. And see, that's another issue. When you're entering the same information twice, I've had to enter Lisa in twice, and human error, I've made a typo in her name the second time. So if I wanted to look up all the dogs Lisa owns, and I said, hey, give me every record where Lisa's the owner, I'm not gonna get that Jake's one of her dogs because I've made a typo. So that's one problem. The other problem is I'm duplicating the data. Okay, and again, duplications lead to lack of consistency in the data. Lacks it to, again, faulty queries, as you can see with the typo, human error, the more you have to type in the same data. So ideally what we would want is to, instead of one big table with all the data like this, what we would want is two separate tables. We would want one table that's owners. Okay, so we'll make an owners.csv. Okay, which would just be owners.csv, which will just be ID, the name of the owner, and the age of the owner. So in this case, we would just say, hey, 1, which is Lisa, who is age 33, and then 2, which is Steve, who's 55. And again, see, I misspelled Lisa already, but at least it'd be consistent. 2, Steve, who was 55. Okay, so there I have my list of owners. And then instead, what I do with dogs, so we'll do dogs.csv. Okay, we're going to have the ID of the dog, the name of the dog, the age of the dog, and then we're going to have an owner ID. So we can track who owns that particular dog. So again, the first two dogs are Biff 4, Jake 8. So let's get those out of the way. So ID 1, that's Biff, which I remember right was Biff 4, Jake 8, Biff 4, Jake 8. So Biff is 4. And again, the owner ID is Lisa, who's the first owner. So that would be the ID of 1. And 1 is Jake, who is 8. And again, also owned by Lisa, who was ID 1. The beauty of this is that this is what's referred to as a foreign key field. It's referring to the primary key of the owner in a different table. And the beauty of this is that now if Lisa changes Lisa's name's only written once, so I only have to get it right once. On top of it, even if I spelt it wrong, I'm still associating it with the right person. I'm still going to find the right information. And basically, I don't have to write Lisa over and over again, so I'm actually reducing the amount of space I'm taking up. And again, reducing the possible human error in all of my data. Okay, and then let's just add the second dog, the last dog, Steve, 55. Well, no, that's not the name of the dog. The dog is Butch, who's 6. And again, I made a mistake on the ID. The ID here should be 2. And then ID 3 is Butch, who was 6 and belonged to Steve, who was the second owner. So now we have our 2 tables. Okay, so we have our 2 tables, and that's referred to as normalization. Okay, so that process of where you take, like, you maybe have a spreadsheet, they'll just kind of list everything kind of like this. Okay, what you would want to do is then break that up into separate CSV files. Okay, or separate spreadsheets, and then export them as CSV files that break down the data like this. Or you can do that from SQL, but the idea of going back and reassessing the data and reducing the amount of duplication in your data by this process, and you can look at each column. Look at each column. If you start seeing like the same value over and over again multiple times, you may want to do that. Like, for example, here I wrote red and blue several times. What I should have done is made a separate table called teams, and this would have just been 1 or 2 instead of red or blue. Okay, so that way I don't have to write red or blue over and over again, and then any other data about like who's the coach or anything like other data about that team specifically could have been in another table, and then I'm just saying, okay, hey, this particular player belongs to that table, belongs to that team who's defined in that other table. Okay, and again, by creating this way, you make your data a little bit more organized, but we can still then see it all together. That's where we're going to get to with joins. But again, this process is called normalization. We're normalizing our data so that way we're having as little duplication of our data as possible. Okay, again, reduces human error. It's also going to make our data take up less physical space. The only trade-off is that when you have multiple tables, when we do these joins where you're taking 2 tables and mushing them together, that is theoretically slower than having 1 table with all the data. So there are trade-offs, okay? Having data take up less space might take reading queries where you read data take longer. And also situations that might help us speed up how fast we can read data might make us take longer to add or write data, and things that might make it faster to write data might make it slower to read data. So there's all these sort of trade-offs. Okay, anything we can do to sort of optimize always comes at a cost. Nothing is free. So always keep that in mind. But you figure out, hey, what is it that's most important to you? Is it the amount of space you take up with your data? Is it the speed of your reads, the speed of your writes? And you learn to optimize for that. Okay, cool. So now that we have these 2 tables, okay, let's just take those files and turn them into actual tables. So let's go over here to our shell and open up SQLite. Okay, so I'm just going to clear this. SQLite 3 first.db, our database. Again, we want to import these CSV files. So we got to change our mode to CSV first, and then we can import the CSV file. So first we'll do teams and teams.csv into not teams.csv, owners.csv into a table called owners. Okay, and let's just make sure, and then we'll do the same thing with dogs. Import dogs.csv into a table called dogs. And now let's just make sure that both of these tables are what we want. Let's change the mode over to table so we get that nice table visual. So select all from owners. Oh, let's not forget the semicolon. Okay, so there's our 2 owners, and then select all from dogs, and see there's our dogs. So now we have our data nice in separate tables. So they're in separate tables. There's no duplication. Lisa's not mentioned twice. But what if I did really want to see the data all joined together like we saw over here? When we saw dog owners, we saw all this data sort of in one place, okay, instead of multiple places. Okay, choose server changes, just let that do its thing. So it kicked me out. So let's me reopen that. Okay, SQLite 3 first.db. Let me just make sure that my table still exists. Tables. Do I have dogs? Yep, dogs and owners. Select all from dogs. Good, has all the data. Okay, but I'm in list mode, so I want to change back to table mode. Cool. So this is where joins come in. We're going to say, hey, technically the way these two tables connect is based on the dogs table. See, in the dogs table, we have that owner ID column. That tells us which owner belongs to which dog. So that can be how SQL figures out, hey, here's where we should add in that particular owner's information to create that nice view. Okay. So the way I can do that is, what you'll do is you'll do select. We'll select all the records from, and again, you want to think about which shows up first. Should the dogs show up first, or should the owner show up first? So which data should show up on the left, and which data should show up on the right? Because you have to think of it like a Venn diagram. Okay. So the first table we mentioned is going to be the left of the Venn diagram. Okay. So on the left, let's say we want dogs. Let's say we want it to look like our original thing here, so we'll do owners first. So select all from owners. Oops. Okay, go over here from owners. And then what we're going to do is we're going to join. We are going to join on. Okay, actually we say join dogs on. So we're going to say, hey, I want to mix these two tables. I want these two tables to become one source, one view of data. I'm not actually making a new table. I'm just giving a query, and it's going to give me back sort of a mush of the data. Okay, dogs on, and then you say, how do you join them together? Like, what two fields should we match up? So the idea is that the owners.id, so that this time you have to actually put the name of the table. So the owners table .id, that's the column, should match dogs.owner ID. So it's going to match that owner ID column. Whenever those two numbers match, that's a match, and that's how you should build out that data view. So now if I put the semicolon here, and see, now I have that data all nicely organized together. Now I may not necessarily, in this case I asked for all the columns, but this may not necessarily be like what I want. Okay, I don't necessarily need to show the owner ID, and this is not clear like what this is the ID for. Okay, and whether this is like whose name is this and whose name is that. So this case is where that as keyword would become pretty useful. So we may want to do something like this, like select owners.name as, or actually we'll do this, select name owners.name owners.age dogs.name, and we'll rename dogs.name as dog name. Okay, and then we will also include dogs.age as dog age. And so that's all the fields we want to include. I'm not going to include the owner ID, any of the IDs, because they're not necessary for the data we really want to look at. There's just more confusing data. And again, that's going to be from owners, which we're going to join with dogs. And how are we going to connect them? On anywhere where the owner's ID field matches the owner ID field on the dogs table, dogs.owner ID. And see, now I get this nicer table that's a lot more clear. Okay, so this is where you start really kind of bringing in everything we've learned and start really kind of like taking advantage of it to make sort of nice views, so that way you have a very nice clear deal. Okay, now that was a long query. I could create a view from that query, so that way I don't have to like type that whole thing in every single time. And then again, so that goes back to that whole idea of creating a view that we mentioned a while back. Okay. Cool. So that is just how you join data. The thing is that when you do a join, it's assuming what's called an inner join. So if you imagine the two tables as Venn diagrams, it's only going to use the data where they both match. What if that's not what you want? So let's add some data to both of these tables. So I'm going to insert into owners. Okay, and I don't think the ID is going to be auto incrementing for these. So I'm going to make sure I give it my own ID. So insert into owners value. So I got to give it, ID and name and age. Values, and then we're going to say, hey, we're going to inject someone who's the ID of 3 because be the third owner. The name will be Yelena, and the age we'll say is 45. Okay, so we insert that. Okay, and then we'll just double check that we correctly added it. So select all from owners. Okay, good. Yelena's been added, but that's fine. Then I'm going to go over the dogs and say, okay, dogs, insert into dogs, and it's getting ID, name, age. This would be the fourth dog. So values for Clifford 5. And then we insert that dog in there. So let's just see, did the dog get added? Select all from dogs. And Clifford's been added. But notice Clifford does not have an owner, and Yelena has no dogs. So now if I do that join again, let's watch what happens. So select, in this case, I'm not going to do the whole like changing all the field names. We'll just say select all from owners, which will join with dogs on anywhere where owners.id equals dogs.id. Okay, notice you end up having this weird situation where Yelena is being mixed with Butch. Okay, even though Butch is not owned. Oh, because I did the join wrong. Owner's ID with dog's ID. So let's try that again. Select all from owners, join dogs on anywhere where the owners.id equals dogs.owner ID, because that's the name of the field over there. Okay, and notice you don't see Yelena and you don't see Clifford because it did an inner join. It only did the middle of the Venn diagram. So it only did where there was a match on both sides. What if I would like to include Yelena? Okay, I don't want dogs that don't have owners. I just want to see all the possible owners and any dogs they may have. Okay, well then I can do this. Select all from owners, and then I'm going to do what's called a left join, which means keep everything on the left. So again, imagine those. So owners is the left because that's the first one I mentioned. Dogs is going to be the right. So I'm saying keep everything that's on the left, including the stuff where they overlap. So left join dogs on where owners.id equals dogs.owner ID. And if we do that, notice now it does have Yelena because I said include everything that's on the left. That's a left join. So include everything that's on the left and anything that matches on the right. Regarding those two circles, which are the two tables. Again, imagining that Venn diagram. And if you're not familiar with what a Venn diagram is, do a quick Google on what a Venn diagram is. It'll make everything I've just said make a lot more sense. Okay, pause the video. It's okay. I'll be here when you unpause it. Okay, cool. Now with that, what if I just wanted to see all the dogs? Okay, I just want to make sure that I see all the dogs so that I can identify any dogs that need to be adopted. I don't really care about owners who haven't adopted dogs. I have somebody who wants to adopt a dog, and I'm just trying to see, okay, who is adopted and who isn't adopted. Okay, so I might do something like this. Select all from owners, right join. So I'm joining on the right, so everything on the right, but only matches on the left. Okay, dogs on owners.id equals dogs.owner ID. Okay. Oops, I forgot what did I forget here? Full outer joins are not currently supported. Well, I didn't do that. Right join dogs on owners. Oh, okay. SQLite doesn't do right and full outer joins. And now it's gonna be the next thing I do. So a full outer join would have been everything on both columns. Okay, so for that we will have to revisit that if we later on shift off the Postgres. Although I think I have Postgres videos already where I do the joins and show you all the different joins. Okay, it doesn't say cross joins aren't supported, so let's try that out. A cross join isn't where you're looking for matches. What it is just showing you every possible combination of the two. Okay, so if I want to see every possible combination of owner and dog, probably a little bit less practical here, but let's say you were running like a dating website or like a dating, what you call those, like speed dating things, and you wanted to create a listing of every combination of all your attendees. So like I want to make sure that every person is matched up for every date with everybody else. So I want to make a list of every combination. You might want to do a cross join to create every possibility. So in this case, what we do here is we say select all from owners, cross join dogs. Okay, I don't even think you necessarily need to do an ID, but let's just we'll say on owners.id equals dogs.owner ID. I don't think I need to do the on, but let's see here. Okay, that's still doing just a normal join. Let's see if I just do without. Select all from owners, cross join dogs. And see right there, it's giving me every possible combination. So see Lisa with every possible dog, Steve with every possible dog, Yelena with every possible dog, because maybe that's the data I need. I'm in a situation where I just kind of need to see every combination of pairs of people here. Okay, so I have that as an option as well. So that should hopefully, again, idea here is, again, when you have lots of data, you want to reduce duplication. So you normalize the data, meaning you break it up into different tables. And you use a foreign key to help identify, hey, well, the way the data matches up. So this thing matches up with the thing with this ID in this other table. So again, each dog is owned by an owner who has this ID in the owner's table. Okay? And then with that data, we can then join the data based on those connector fields. Okay, so whatever field is that helps us determine how these things connect, we can then do a join. That allows us to kind of see the original sort of put together data without necessarily actually having to create duplicates in our database. We're not having to write, even though I can see Lisa here multiple times, I never actually had to enter Lisa multiple times in the database, which means if I were to update that one record of Lisa, okay, it'll automatically update for both dogs. And that makes my life a lot easier instead of me having to update it for two dogs because I have two entries. Okay, so hopefully that all is clear and helpful. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.